Good morning, my Algebra students. So yesterday, or last time we met, we talked about solving for our x values when y is 0. We call this just solving for the x's or solving for the zeros when y is 0. Today we get to learn a little bit of a shortcut when we have square roots, right? And this will lead us to other bigger concepts of shortcuts and how we get the quadratic formula from these concepts. But first, let's just talk about how do we solve quadratic equations using roots. And we talk about roots, we mean square roots, right? Because we're looking at perfect squares. So let's remind ourselves what a square root is, right? I know that 3 times 3 is 9, right? Or 3 squared is 9. And I know that the square root of 9 is 3, right? And that is our concept understanding until we are in high school. In high school, we start to think, you know what? There's more to this than we think. It's also -3 times -3 could be 9. Therefore, the square root of 9 could be plus or minus 3. Plus or minus 3, because it could be 3 times 3, or it could be -3 times -3. So we have to wrap our mind around the fact that there's the two forms of every square root could be a positive form and a negative form. And that makes sense. Because when you think about our x's, we know that there's always 2 on the number line. So now we know that there's like a +3 and a -3. Let's look at this one. So if I'm solving using square roots, if I say that x equals 16, well, I could subtract the 16 and put it in standard form, and I would see it's a difference of 2 squares, right? Or I can just square root both sides and know that it's plus or minus 4. Let me just remind you, excuse me, again, that if I have x squared and I subtract the 16 from both sides to put it in standard form, then I would have here, if I were to solve by factoring, I'd get x minus 4 and x plus 4, and then I would solve when they equal 0, right? And I'd add 4 to both sides, and I'd get x is 4. Subtract 4 from both sides, and I'd get x is -4, right? So same answers, plus or minus 4, right? But a lot less work. So these are the shortcuts. As long as we understand the concept of square rooting and that there's a positive and negative version, it's a shortcut. Let's take a look at this one. Mental math here. If I square root both sides, what am I going to get? Yeah, I think you're right. Plus or minus 6. Plus or minus 6. So if I have here, I square root, and I go, oh, wait a minute, there's no square root to 18, but we call this a simplified radical. Simplified radical, which just basically means I look inside here to see if I can take any square roots out of it, right? So when I look inside, I look for the largest factor that is also a perfect square. So we know that 18 is 9 times 2. Now I cannot square root 2, but I can square root 9. So I square root the 9. And so I have x equals plus or minus, right? There's a little reminder here. You have to show all these steps on a quiz or a test. Plus or minus this 3, because we're going ahead and squaring that out, times the square root of 2. And when you get into Algebra 2 and pre-calculus, you'll see that you can have 3 square root 2 is something on the unit circle, but we'll get to that later. It's sort of like having a grid that we use for our number lines. We know there's negative numbers and positive numbers. Well, on the outside of a circle, there are radiuses that have so anyway, x equals plus or minus 3 square root 2. 3 square root 2. Now, if I wanted to do the decimal form of it, then I would do the square root of 2 and multiply it by 3, and I would get 4.27. And there's times we want an actual number like that, but for the most part, right now, we want simplified radicals. Okay, so let's take a look at here. You can start to see how crucial it is to understand what makes up numbers and understand, honestly, your multiplication tables, because it makes it so much faster to look inside a number. So on 48, we could see it's 16 times 3. So I could square root the 16, so I'll have x equals plus or minus 4 square root 3. Again, I could also do the decimal form, but for our purposes, we really want to practice this simplified radical. Why don't you guys try this one? Pause the video and see how you did. Okay, now this is a large number, so what could I do to figure this out if I can't see it right away? Well, I could factor 96, right? And I know that's 2 times 48, 2 times 24, 2 times 12, 2 times 6, and 6 is 2 times 3. And then I can look at all my pairs to take out, right? I have 2 sets of 2, and then I have the 2 and the 3. So now I know 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So what I have here is 16 times 6. And so I could square root 16, because we know that's 4, so we'll have plus or minus 4 square root 6. What if it's a fraction? How do I do this? Well, you just square root like you normally would. You know the square root of 4 is 2, the square root of 25 is 5. So you'll just have plus or minus 2/5. Now this is x squared equals negative 64. Let's think about this for a second. Can I square root a negative number and also have a positive to it? No, because it's not a real solution, because I don't have a number that can multiply it by itself and equal a negative, right? It's either a positive times a positive or a negative times a negative when we're talking about real numbers. Now, when you get to Algebra 2, there is this little thing called imaginary numbers, and we represent that with the letter I, and I is the square root of negative 1, right? So you can substitute this in there, and it helps a lot. But for our purposes right now, we're going to say it's math illegal to square root a negative number. So if you have that, you know it's not a real solution. Go ahead and pause the video, try these, and see how you did. All right, let's check our work here. We have plus or minus 7, and then I could take the 4 out, so I have plus or minus 2 square root 2. And then with the fraction, the square root of 9 is 3, the square root of 16 is 4. So I have plus or minus 3/4. So now let's solve using square roots, right? If I'm solving, I need to isolate the root first. So I need to isolate the x. So I divide by 2 first. Just like when I solve for any equations, isolate x. And now I can square root. Let's look at it again. If I have a more complicated equation, I could first isolate my x, so I need to add 6 because I use my inverse operations and PEMDAS backwards. So to isolate, I always want to subtract or add before I multiply or divide, and then use our exponents, which is what we're doing here. So I get here, divide by 3, and now I can square root. So plus or minus 3, plus or minus 3. Okay, so just let me remind you one more time that PEMDAS orders of operations, right? We do parentheses, we do exponents, we multiply, we divide, we add, and we subtract when we are evaluating a side of an equation, right? But when we solve, we go backwards. We start here. We start by adding or subtracting, then we multiply or divide, and then we get to the squaring, which is what we're really practicing in all of this lesson right now. Okay, let's see how it works. So I'm going to add the 25 to both sides and divide off the 4. And I leave it as a fraction because I know I could square root these, right? Then I square root, and I get plus or minus the square root of 25 over the square root of 4, or plus or minus 5 over 2. On number 4, let's take a look at this example. I'm going to first divide by 2, and then I get the square root of 45, which is not even, so I have to look inside, and what do I see inside? I see 9 times 5. So I can square root the 9 and have plus or minus 3 square root 5. Okay, let's have you guys give it a whirl and see how you do. Pause the video and then check your solution. Okay, I'm going to isolate my x by subtracting 8 from both sides, dividing by 4, and then getting my square root of 4, which is plus or minus 2. Okay, let's solve for quadratic equations now using square roots. So if I'm solving using roots, I know that x plus 2 times x plus 2 is a perfect trie, right? Or x squared plus 4x plus 4, right? This is what this looks like. And we're saying it equals 9, right? Now, if I were to solve factoring, I would have to factor this, and I get here, right? The other way to do it is to subtract the 9 from both sides, and now you're trying to factor, this, right? But let's just see the shortcut here. The shortcut is I can square root both sides, and I get x plus 2 equals plus or minus 3. Now, I haven't all the way finished. I have to then subtract the 2 to isolate x, but I have to subtract the 2 to 3, and I have to subtract the 2 to negative 3. Gotta clean my board here. So my answer are going to be 1 and negative 5. Let's look at that again. If I have this already factored, right, it's a perfect square, a perfect trinomial square. So I can, instead of having to factor it out and subtracting the 16 to put it in standard form to then factor again, I can just square root both sides and get x minus 5 equals plus or minus 4. Isolate x, I have to add 5 to both a positive 4 and a negative 4. So I'll get 9 and 1. 9 and 1. Let's try it again. What happens if it's not a perfect square when you go square root? Well, that's okay. I can still look inside and square root what I see, right? Just like I did every other time. And I know this is 4 times 6 or 8 times 3, but I'm going to go ahead and do 2 square root 3 because I took out the 4. And now I still have to solve for x, right? So I have to add 8 to all of this. So I'll get x equals 8 plus or minus 2 square root 6. Now, if I were going to go ahead and solve it all the way where I wanted an actual value for each x, then I would have to solve for 2 times square root of 6, which is 4.9. And then I have to do plus or minus. So I have 8 minus the 4.9, 8 plus the 4.9, and I would get 3.1 and 12.9. Let's go ahead and have you guys try this and see how you're doing on it. Okay, let's check it. So I square root to solve, and then I add 4 to both positive 6 and negative 6, getting negative 2, 10. Today for practice, we have a puzzle that I would like you to show your work on paper. And we have the textbook problems 35 through 39 and 57 to 60. And on the puzzle, it says that so you don't forget. All right, have a great day.